Greetings everyone. Today we are going to explore graphing functions from a table. We do have a notes foldable for this. It would be helpful if you don't have it to at least have maybe some printed graphs or some graph paper. To start off, let's go through some steps. How to create a table. Now, do you have to think and memorize each one of these steps? No. But it's a good place to start and to reference. So the first thing we're going to do is we're going to isolate the output. Now, think about the letters, the synonyms, right? Output also means the y value. Remember that from our previous lessons? So if you think about it, we're solving for y. If that makes more sense to you, maybe write solve for y. Step 2, you're going to use or choose at least 5 x values. So we're going to have a table. It's going to have an x column. Now, sometimes I'll give you the 5 values. Other times, you want to pick 5 x values. We're going to talk about what x values would be the best, what strategy might help you with step number 2. Step 3, we're going to substitute the x values into the function, meaning plug x in. We're going to plug in x, solve, plug in x, solve. Step 4, simplify. That's what I mean by solve. So if it says 3 times 2 plus 7, calculate that. What we're going to create is a table with x's and y's. Well, x's and y's make coordinate values. So we're going to plot those dots. Step 6, we're going to continue to work on identifying the domain and range of our function. All right, let's start off with this example. Step 1, isolate the output. So remember from our previous lessons that if x is here, this represents y. Okay, f of x is function notation, which is used the same way a y value is. So that means that the output is already isolated. Y is by itself, meaning I have this nice clean equation, right? Step 2, use or choose 5 x values. Now, ideally, the first strategy to think about is I would like to have 0 in the middle and pick the next smallest values on either side. This is going to be your typical go-to. We'll talk about when it's not good to pick these values, but in general, this is a safe bet. Step 3, we're going to substitute the x value into the function, meaning if these are x's and this says x, I need to plug them in. So if I follow my function, it says negative 3 times x plus 1. 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 Instead of x, though, we're going to substitute in the x value, right? So we chose negative 2, negative 1, 0, 1, 2. That's why we use those x values, so we can plug them in. The next step, we're going to simplify that line of work. So negative 3 times negative 2 is 6. 6 plus 1 is 7. And you don't even have to show this. The calculations should be simple enough that we could just use mental math. Negative 3 times negative 1 is positive 3. The plus 1 takes it to 4. Negative 3 times 0 is 0 plus 1, 1. Negative 3 times 1 is negative 3, plus 1 is negative 2. And negative 3 times 2 is negative 6, plus 1 is negative 5. Now, one of the ways you know you're on the right track is if you see a pattern in your answers. So if I take a look, I'm going subtract 3, subtract 3, subtract 3, subtract 3. That's good. You don't have to pay attention to that pattern right now. I just want you to acknowledge that there is one. Because if the numbers are all over the place, something's wrong, okay? All right, the next step, we want to plot these dots. So if I take a look, I have the x value of negative 2 and the y value of 7. See how I created that point? x value, y value, x value, y value, x value, y value, x value, y value, x value, y value. We created 5 dots that we are going to graph on our graph. -2, 7, -1, 4, 0, 1, 1, -2, and 2, -5. In this unit, everything we are going to do is going to be a line. If it doesn't make a line, you guys, do not leave it. It needs to be a line in this unit. That's a hint. That's a way to make sure you're correct. Show me that you can connect the dots, draw arrows on the ends, and we've created our line. Okay. Next, you'll notice we have some questions up top. What type is this? This is linear. Okay, it means what kind of graph, what type of function did we create? So most of these are going to be linear, as I said. Domain, how far left does that graph go, that line? It goes forever left. How far right does that line go? Forever right. How far down? Forever to negative infinity. How far high? All the way up to infinity. This is always the domain and range for these types of diagonal lines. Unique, right? So that's going to help us with our domain and range. Let's take a look at the next one. Very similar, so I'm going to go a little bit faster. First step, isolate the y. Yep, already by itself. Second step, use or choose 5x values. I'm going to stick to those same 5x values, meaning the smallest numbers I could possibly use that are integers. Step 2, plug the x values into the function. 2 times x minus 2, 2 times x minus 2. Notice I like to repeat myself. It helps me remember what I'm doing and makes it easier to plug in those x values. Next step, we want to calculate. 2 times -2 is -4, minus 2 is -6. 2 times -1 is -2, minus 2 is -4. 2 times 0, 0, minus 2, -2. 2 times 1, 2, minus 2 is 0. And some of you might be looking, you're like, oh, I'm adding 2 every time. I'm okay with that. If you're confident and you're sure that that pattern will continue, then go for it. Recognize that pattern, +2, +2, +2. See how I'm making those jumps and they're the same? That's good. If you don't have a pattern, what's going on? Something's wrong, okay? All right, let's graph our points. I see that I have -2, -6, -1, -4, and you don't have to write out these points. If you can read the table clearly and you understand that, jump straight into the graph, okay? -2, -6, -1, -4, 0, -2, 1, 0, 2, 2. See how it's making a perfect line? It will always make a perfect line in this unit. All right, my type, still linear. If it's a diagonal line, it goes forever left, forever right, and it goes forever down, and it goes forever up, bottom to top. All right, first step, isolate the y. Yep, check. Step 2, use or choose 5x values. Now I'm still going to use 0, but let's stop for a moment before we do anything else. Take a look at what I'm going to do to that x value. I'm going to times it by a third. So imagine taking 2 times a third. That'd be 2/3. Ooh. Or times 1, that'd be 1/3. I don't know about you, but I don't want to graph 1/3 on this little graph. So the strategy here is I'm going to pick numbers that divide by 3. Because that's what it's saying. It's saying divide by 3. So let's think of the smallest numbers that I can divide by 3. Well, that would be -3 and 3 and -6 and 6. See how I did that? I chose multiples of the denominator. That's going to make things a lot easier. Now, do you have to do that? No. Will it make your life way easier? Yes. All right, let's set up our equations. I have 1/3 times x plus 5. 1/3 times x plus 5. I like to do it this way. You can write it all in one shot if you're more confident. I like the repetition piece. I'm going to substitute in my x values, -6, -3, 0, 3, 6. Now, I'm going to start with the 0. You guys don't have to go top to bottom or bottom to top. I'm going to start in the middle because 1/3 times 0 is 0 plus 5 is 5. Right? Now I have a number to go off of and make sure my pattern works. Next, I'm going to go down. 1/3 times 3 is 1. 1 plus 5, 6. Oh, okay, let's see if this pattern continues. 1/3 times 6 is 2. Plus 5 gets me to a nice clean 7. You see the pattern? 7, 6, 5, 4, 3. Make sure your work matches though, right? If your work doesn't match your answer, I want to know that we've got some misunderstanding here, so make sure. 1/3 of -3 is -1 plus 5. That makes sense. 1/3 of -6 would be -2 plus 5. Perfect, it worked out. Now we can plot our points. This time I'm not going to write them out. I'm going to read it. -6 is the x, 3 is the y. -3 is the x, 4 is the y. 0 is the x, 5 is the y. 3 is the x, 6 is the y. Whoops, 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 whoops. I lost a dot there, didn't I? Let me fix that. There we go. And notice I stopped because I wasn't seeing a nice clean line. I knew I had to fix something, right? And then I know I have 6, 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. I got my perfect diagonal line. That's what I needed. Connect and draw arrows. Yes, arrows are important because arrows tell me that I am going forever left, forever right, and forever down and forever up. Type still in here. Yes, we've got another one. Bear with me. If you can pause and jump ahead and do these on your own, fantastic. Please do so. First thing, isolate y. Done. Step 2, use or choose 5 x values. 0 in the middle. I have a denominator of 2, so I want factors of 2 to make my life easier. Do you have to? No. But again, it makes it easier because now I'm going to have 1/2 times x minus 4. 1/2 times x minus 4. Yes, I want to see the work. I'll always give you a spot on your paper for your work. That is an expectation. Let's fill in our x values. X, 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 x. I'm going to start in the middle because 1/2 times 0 is 0 minus 4, -4. 1/2 times 2 is 1 minus 4, -3. 1/2 times 4 is 2 minus 4 is -2. Sweet, I see a pattern, that's good. 1/2 of -2 is -1 minus 4 is -5. 1/2 of -4 is -2 minus 4 is -6. Good deal, we see the pattern, let's graph the dots. -4, left 4, down 6. -2, -5. 0, -4. 2, -3. 4, -2. We're going to draw a line, draw arrows, and identify that again we have a linear function that goes left to right forever and bottom to top forever. Alrighty, so as you've noticed, I've been kind of zooming through the domain and range. If you need more help with that, see the previous video. Our first step is to isolate y. Now, it is by itself, but take a look at that right side. If you can simplify it, you probably should, meaning I want to distribute. I'm going to make it a negative 2x plus 1. So there's no parentheses, no like terms, right? Break it down to the simplest form. Use or choose 5x values. I'm going to multiply by 2. There's no fractions involved, so I'm going to keep the typical 5 points. And I'm going to plug in my x values. Now, I'm going to write this all in one shot. I'm going to go a little faster. Negative 2 times negative 2 plus 1. Negative 2 times negative 1 plus 1. So I'm taking a different approach than the previous slides. I'm filling in that x value right away. I want to calculate. I'm not going to show additional work. I'm just going to multiply. So at this point, if you need a calculator, of course, use that. Also, show more work if you feel like you need it. Okay. Yes, I'm going a little faster because the calculation piece is not what this lesson's about. The lesson's about the setup and then plotting points. I have a negative 2, 5. I have a negative 1, 3. I have a 0, 1. I have a 1, negative 1. I have a 2, negative 3. Did I make a perfect line? Sure did. So let's connect the dots, draw arrows, and identify that this is still linear. Forever left, forever right, bottom to top. Now this one I chose because that negative in front can kind of throw you off. So first of all, y is isolated. Second of all, I'm going to write it as negative 1 times x, just so I don't mess up that negative. Because when I use or choose my 5x values, I'm going to have negatives, right? So I just want to be careful that when I write negative 1 times x minus 2, see how that's going to be helpful? That way I have all my signs written carefully. I'm going to fill in my x values. And I'm going to calculate. Negative times negative, positive 2 minus 2, 0. Negative 1 times negative 1 is 1 minus 2, negative 1. Negative 1 times 0, 0 minus 2. Negative 1 times 1, negative 1 minus 2. Negative 1 times 2, negative 2 minus 2. Perfect. I got a nice clean pattern. Negative 2, 0 on my graph. Negative 1 on my graph. 0. Oh, what am I doing? Oh my goodness. Let's try that again. I did it wrong, didn't I? Negative 2, 0. Left, then not up or down. Negative 1, 0, negative 2. 1, negative 3, 2, negative 4. So I knew that I was wrong because it wasn't working out to be a line. If it doesn't work out to be a line, stop, restart. What happened? We need to fix that. Okay. I got a nice clean linear function, same domain and range. I know that seems repetitive. Yes, we will have other domain and ranges, but for now, for lines, that's what we have. As always, make sure you check Google Classroom. We're going to be working with these linear functions all unit. Make sure you keep caught up. Make sure to check PowerSchool if you're not sure what you're missing. Let me know if you have any questions, and until next time, have a good one.